Hello, welcome back. Today we're going to be solving for the missing sides and angles of a right triangle. The objective is that by the end of this video, you should be able to use the things called sine, cosine, and tangent to find the missing sides and angles of a right triangle. Now we're going to define some important terms for a right triangle. The first of which is the opposite side of an angle. If you have an angle, the opposite side is the side that's across from or on the other side of the angle. The hypotenuse is the side that is across from or opposite the right angle. Now it specifically has to be the right angle. The side that is adjacent to an angle is the side that is next to, near, or close to the angle. The hypotenuse is never called the adjacent side. That's a very important note to make when we move on to identifying the opposite side, hypotenuse, and adjacent sides. Given the triangle below and the definitions we just got through learning, see if you can identify the side that is opposite angle A, the side that is adjacent to angle A, and the hypotenuse of the triangle. Go ahead and try to do that in your mind. We'll go over the answer here in a second. Starting with angle A, the side that is opposite angle A is the side that's across from angle A. So this side is opposite of angle A. The side that's adjacent to angle A is the side that is next to, near, or close to angle A. The side that's real close to angle A is this one right here. This we're going to call the adjacent side. So this side is adjacent or next to angle A. You might notice that this side is also adjacent angle A, but since it is across from the 90-degree angle, it's the hypotenuse. And we never call the hypotenuse the adjacent side. The reason for that is because the hypotenuse is a very special side that's always across from the 90-degree angle. On your own, and just in your mind, see if you can identify the side that's opposite angle B, the side that's adjacent to angle B, and the hypotenuse of the following right triangle. If we look at angle B, the side that is opposite angle B is this one right here. The side that's adjacent to angle B is this one right here. And the hypotenuse, which is across from or opposite the 90-degree angle, is right here. We're going to learn some new functions that allow us to find the missing sides of a right triangle. The names of these new functions are sine, cosine, and tangent. Now each one of these is going to be defined in a different way. The sine of an angle is equal to the length of the opposite side divided by or over the length of the hypotenuse. But this is way too long to write. Nobody ever wants to write out all those words. So we're going to abbreviate this using sine of angle A is equal to the opposite side over the hypotenuse. Likewise, we're going to abbreviate cosine and tangent using these. Cosine of angle is equal to the adjacent over hypotenuse, and the tangent of an angle is equal to the opposite side over the hypotenuse side. Now we can remember these using the acronym Sohcahtoa. S-O-H-C-A-H and T-O-A. S-O-H stands for sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Note, we will not be using sine, cosine, or tangent of right angles in this class. Second note, and probably more importantly, you'll have to memorize these functions: sine, cosine, and tangent. Now that you've got those written down, let's look at them, or rather do them, for the following triangle. Find the sine of angle R. Now, to find the sine of angle R, I'm going to look at angle R, and I'm going to remember that sine, S-O-H, is going to be equal to the opposite, that's the O, divided by the hypotenuse, that's the H. So I'm going to write that to help me remember: opposite over hypotenuse. So looking at R, what's opposite angle R? The side that's opposite angle R is 45. The hypotenuse of the triangle, which is across from the T, is 53. So the sine of angle R is equal to 45 divided by 53, because that is the opposite side over the hypotenuse. Let me find the sine of S. Again, the sine of S is going to be the opposite over the hypotenuse. But this one's going to be a little bit different because it asks us for the sine of angle S. See if you can write the fraction that's equal to the sine of S. Alright, we know that sine of S, again, is the opposite side, so the side that's opposite of angle S is 28. The hypotenuse of our triangle is still 53. Let's find the cosine of angle R. Looking at R, cosine is going to be adjacent over hypotenuse. So what side is adjacent angle R? The side that's adjacent angle R is 28. So it's going to be 28 over the hypotenuse, which is 53. See if you can find the cosine of S, the tangent of R, and the tangent of S using what we've just got through learning. Okay, the cosine of S. We're going to take a look at S, and the cosine of S is the adjacent over the hypotenuse. The side that's adjacent angle S is 45. The hypotenuse of our triangle is 53. What about the tangent of R? To find the tangent of R, we're going to do opposite over adjacent. Or, remember, tangent is toa. O and A stand for the opposite and adjacent. So, looking at R, the side that is opposite angle R is 45. The side adjacent angle R is 28. Let's find the tangent of angle S. The tangent of angle S is the opposite side of S, which is 28, over the side that is adjacent angle S, which is 45. Go ahead and try this one on your own. Find the sine of W, the cosine of W, and the tangent of U. Pause the video and press play when you're ready to see the answer. Went ahead and did the first two for you. For the third one, tangent being the opposite over adjacent, toa, we look at U, and the opposite side of U is 24, and the adjacent side to U is 18. Now, for right now, we're not reducing these fractions, and later you can use your calculator to go ahead and write those as a decimal if needed. Go ahead and on your own, try to find the length of MD. Again, the way you're going to start this out is you're going to look at the angle you're given and figure out what MD is that the opposite, adjacent, or hypotenuse. Look at the other side you're given and decide whether you can use sine, cosine, or tangent. Go ahead and try that on your own and press play when you're ready to see the answer. Alright, looking at sine 50, or rather looking at 50 degrees, I notice I have the opposite side and I have the adjacent, which is the side I'm trying to find. I'm going to call that x. Which ratio gives us opposite and adjacent? Looking at our acronym, Sohcahtoa, we notice that opposite and adjacent, or OA, occur with TOA. So we're going to use tangent of the angle, so tangent of D is equal to the opposite side, 21, over the adjacent side we don't know, which is x. So the tangent of 50 is going to be equal to 21 over x. In order to solve for x, we make a proportion. We multiply the two that we have that are across from each other, the 21 and the 1. And then we divide by tan 50. Let's take a look at what that looks like on a calculator. 21 times 1 divided by tangent of 50. Now, if you haven't changed your calculator mode since the last time, it should still be in degrees. We notice it's still in degrees, so we go ahead and press enter. The answer should be 17.6. So when we find the length of MD, we find out it is 17.6. Now we're on to our last type of problem for the day, which is to find the measure of an angle. Notice we're given two sides, but we do not have angle A, which is what it's asking us to find. So to do that, we're going to follow a process that's a little bit similar to what we just got through doing. I'm going to look at angle A, and I notice that I'm given the opposite side, and I'm given the adjacent side. Which ratio gives us the opposite and adjacent? If you remember, it's the tangent of A that gives us the opposite over the adjacent. So, the tangent of A, we don't know still, is equal to the opposite, which is 15, over the adjacent, which is 20. Now, did the question ask us to find the tangent of A? The answer is no. It asks us to find angle A itself, its measure. So to do that, we're going to do the last kind of weird thing for today. We need to get rid of that tangent so that we have nothing but A by itself on this side. To get rid of a tangent, what you do is you take the negative or inverse tangent of both sides. Rewritten, notice the tangent -1 and the tangent will cancel each other out. You're left with A is equal to tan -1, the inverse tangent, of 15 over 20. In other words, when you're trying to find an angle, you don't use the regular tangent, you use the inverse tangent. And inside the parentheses, we put the opposite over the adjacent. Let's take a look at what that appears like on the calculator. To get the tangent -1, what we do is we type second. You see where it says tangent, we type second tan -1, the opposite side over the adjacent side. And we press enter. We notice that we got 36.9, but I forgot a key step. Make sure your calculator is in degree mode. We notice it is, so 36.9 is our answer, which means the measure of angle A is equal to 36.9 degrees. Alright, on your own, go ahead and try to find the measure of angle C. Pause the video and press play when you're ready to see the answer. When I was working it out, I noticed that I had the opposite and the hypotenuse. So thinking about Sohcahtoa, which one gives you an opposite O and a hypotenuse H together? The answer is SOH, S-O-H. The opposite over hypotenuse is the sine. So the sine of our angle, C, is going to be equal to the opposite side, 9, over the hypotenuse, which is 22. If you remember the shortcut, we can find the angle C just by going C equals sine -1, 9 over 22. We type that in our calculator, making sure it is in degree mode, which it is, and we get second sine -1, 9 divided by 22. Enter. And you get 24.1 degrees. That's the measure of angle C. Go ahead and try to find the measure of angle A on your own, pressing pause, press play when you're ready to see the answer. Alright, looking at angle A, I noticed that I was given the adjacent and the hypotenuse. Which trig ratio gives you adjacent and hypotenuse? The answer is cosine. So the cosine of angle A is equal to the adjacent over the hypotenuse. Or, since we're trying to find the angle, we can skip straight to A is equal to the cosine -1, or cosine inverse, of our adjacent side, which is 10, over our hypotenuse, which is 16. So we go to our calculator, and we go the cosine inverse of 10 over 16. Press enter, and we should get 51.3 degrees. And that is the measure of angle A.